This, of course, is just an example where we saw yesterday with SQL injection attacks and cross-site forgery attacks where people are trying malicious things to get in. And without us capturing this information, we're not going to be told. We won't find out, shall we? So there's something I want to show you similar to this, which is kind of on that sliding scale of attack vectors. It's similar in spirit to that with another class of attack. You can see the screen, right? I'm guessing that's...
Yeah.
Perfect. Yeah, so this one is one other class of attack altogether, which is going to be vulnerable if you are on a server, if you're, again, using the same language, HTML, CSS, namely that of cross-site request forgeries. So this one's a bit more of a mouthful, CSRF, but again, relates to this, where to a mistake you might otherwise have made when you're writing software on a server, if you're not familiar with this kind of threat, whereby, well, first of all, remember, so HTTP, recall, HTTP is a protocol, this convention, by which web browsers and servers communicate. Well, it turns out that there's different ways that browsers can get information to a server, and one of those ways is literally called get by convention. In other words, like inside those virtual envelopes, typically inside of this word get, followed by the file name. We saw this yesterday with those within Zap, like you would get something at this URI, the file name, that's the browser's trying to get from a server. But more importantly for our purposes is whenever we're using this get method to send information to a server, all this information that you want to get is embedded inside the URL itself. So you can see this as like a long string of characters. And that has a few implications. What that means for us then is, so consider, for example, this is a sample link. I have an anchor tab here at the beginning. Is my anchor tag ending. So close, open. But notice that here is this buy now section. Yeah, so I've got this text here of buy now. Why is that not showing? Is that not working? Why? Let me just close this up, sorry. It'd be easy if I close it and restart it. Oh, behave. Why are you doing this? Okay, I can't, for whatever reason, show that right now. But back to this. Okay, so with the buy now section, again, proposing that in the UK at least, like if you go to amazon.com or .co.uk, there's actually a feature of Amazon where you can buy now. Maybe you've seen this before, maybe you've used it. That is to say that when you go to a page on a product on Amazon, have you ever used this? Like just
too much.
Yeah. The point being that you can just, add items to your shopping cart and check out and then choose your payment method and, some number of clicks later, actually buy the package. But rather than doing that, if you just buy now, if you configure your account in advance, you can go to any product page, literally click a button or click a link that says buy now, and then that's it. Just in one single click, for better or for worse, that product will be shipped to your home. So how might Amazon actually be implementing such a thing? Because they might indeed they use a link like this one. So this is the href, the hyperlink reference to say this particular URL, https www.amazon.com/db/ blah, 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 blah. Okay. In other words, that seems to be enough information on that URL alone via which to buy the product whose unique identifier here apparently is of this string at the text of the word. Okay. Now that's all fine and good. And that seems to be very user friendly, because with a single click of a button can buy a bunch of toasters or something, just buy the product. But the danger is that if this link is not just on Amazon.com, but in like a bad person's website or maybe like an email I sent out to you, it's that easy for you to buy something now. Yeah, you could just trick someone to buy someone now, potentially into buying things that they didn't actually intend to do in that case, or doing anything else on a web server in which they're already logged into, if in get is the method that's being used to get something from that server. Which, well, that is exactly why, because, well, the reason it's problematic is, for example, if following the HTML instead, suppose that you go to a bad person's website and a hacker's website who just likes to make problems again in the world, and that bad person's website doesn't even have an anchor tag or, like a link that they wanted to trick onto. So it's not even as deliberate as a phishing attack where they want you to click on that link somehow and maybe make a mistake yourself. Suppose, though, even sneakily, they're using something like an image tag, which, as it turns out in HTML, so IMG, image for short, that's how you embed an image on a web page. You can see evidence of this going to literally anything. Probably even this, for example. Let's have a look. For example, that alone there. Maybe not that example, but let's go for the diagram at the beginning. This image, for example. There you go. That's how so that's the kind of anchor link you would expect. IMG image source, followed then by that URL, which we're talking about there. So that is there, if I click through to this, that's the address at which you're able to then find that particular image. Make sense? So strictly speaking, that's how you embed an image on a web page. The way that we specify that image, you have to specify the SRC, the source thereof, SRC for short, the value of which I just opened up there, is really just the URL of the name of the image that you want to display, sometimes embedded in the page. Hope that makes sense. But strictly speaking, the URL itself doesn't actually lead to an image in this case here, okay? It could potentially lead to an Amazon product page. But the way that images work on web pages, recall, is that typically when you visit a web page, the images sort of load automatically. You don't have to click or you don't have to do anything typically. You just open up this lab instructions and the image just loads, okay? This embed happened on your behalf. Typically for the images just to appear on the web page, sometimes you get that in emails, maybe that's like anti-phishing mechanisms, but in web pages, typically you don't have to click on anything to see the image. That's to say, the value of the source attributes just automatically downloads and displays things to the user. Now, this in fairness, this is not an image, but the browser doesn't necessarily know that from the get-go. How can it really tell them apart? Because it's just a URL. And so if the HTML in some bad person's website is that somehow you've been tricked into visiting, and you don't even click a link, you just visit that web page, you just land on it, that means that image tag is now going to try to download this source. And even though it's not going to get an image, it's instead going to do this bad thing of buying the product for you. Why? Because if you have logged into your Amazon account, if there is a cookie that's active, even though it's in another tab somewhere else, it's as if though your browser requested that URL, that get method, because of all of the relevant information that buying a product in the URL alone is. So it turns out that then get is actually not a good thing when it comes to changing states on a server to get technical, like the get method is meant to be the safe version, whereby like get doesn't change any state or any values on the server. So it would actually be incorrect, like, or definitely bad practice at worst by Amazon if they were implementing their buy now section with simple like just a a get URL and a simple get request. It should not be that easy to buy things on the internet, okay? Let alone change state on the server in other ways. There are thankfully other methods, post amongst which, that are, but even these are potentially vulnerable as well to this kind of attack. There's a post method, which is typically used by browsers when you want to post your credit card information or your password, you want to post that over to a server. You don't want your credit card, you don't want your password typically ending up in the URL to the browser for privacy sakes, for obvious reasons. So rather, post will kind of hide or obfuscate more deeply in that envelope, to which we'll just keep alluding to. So post might also be used if you want to upload images or you want to upload video files to a server, because those don't really fit in a URL, so it would seem. And post then is an alternative to that is meant to change the state on the server, for instance, to buy products for you. But even this can be abused, okay? And just to show you an example of how it can be abused, some more HTML, I know, again, this is more HTML than we've seen thus far, but we'll just wrap around our minds each piece of it, okay? This, again, represents an alternative implementation of the buy now button on Amazon's thing that is no longer just a single ad tag anymore with everything that's needed in the URL. So this is more like a traditional web form, and it's fine if the form is super, super short and it just only has one single button. That's okay. It doesn't need any text fields. It doesn't need anything like that, but there is still a lot going on here. So just to see, you've got a form tag, okay? You've got an opening tag and a form. So there's a close tag at the bottom, open, close, everything, at least some HTML would expect that going on. So everything in between those form tags here must be implementing this idea of the form, the action of the form, okay? So I say this is going to be able to submit information to Amazon.com or this URL there, Amazon.com, but the method that we're going to use is explicitly post, okay? So it turns out then in HTML form, like if you don't specify the method, it will fall back on get by default. So explicitly what I'm saying is I'm at least using post because I don't want everything to be in the URL alone. Well, I've got two inputs here, one of which is type hidden. And well, what's going on here? So in HTML forms, you can create key value pairs that you send input to a server with. So if you recall previously, we talked about this part here is like separating Amazon.com from like the product ID. And here, like I'm making this up for the sake of discussion, okay? I'm supposing that Amazon supports a web form named DP. That's just who it is, whose type is hidden because the user doesn't need to see this, but the value is that same product ID. So this is an alternative to embedding that product ID in the URL. Instead, I'm saying that there is a HTTP parameter called DP, the value of which will be this, but it's hidden. Okay, so the user doesn't even see it, which is fine, because that's the whole point, is a nice, simple now, buy now button. How do we get that button? Well, when we use that button tag in HTML, the product of which is just submit, because its purpose in life is just to submit the form, the text that the user sees for the button is simply just buy now. Okay, that's what's going to be written on the front of the button. So what am I doing? Like, this will make more sense. Admittedly, to those maybe have studied a bit of web dev before, but maybe written HTML before. Essentially, I'm just making it harder for the adversary to automate an attack on the user's Amazon account. Why? Because I'm not just using a single a link anymore to a user that you might click a URL that could be subtly hidden in an image tag. Now I have an actual web form. And at least based on my naive understanding of HTML at the moment in history, it would seem that the human click on an actual web form, that button, like I cannot use this source as an image. It's not a URL. It's all of this complexity. So again, if you're familiar with get versus post, you might be inclined to think, okay, well, post surely solves that problem using a web form because you can make this in a way that if someone clicks a button before they can buy anything, well, it turns out that not just using HTML, but this language we've seen a bit of today already, namely JavaScript, that can be used to automate the process of submitting the form, so that if a bad person now has the HTML in the website, they don't have to just wait around and hope that someone like you or me is going to go and click along the button explicitly, because that would be a little bit weird if clicking a button thinking you're going to buy something now, but it's not actual Amazon.com. That line doesn't matter. If the bad person here can just trick you into visiting the website, and the website contains this HTML and this additional JavaScript at the bottom, that can immediately or automatically submit that form for you to Amazon.com without you clicking a thing. Why? Because again, inside this script tag that I've added down below in yellow, I've simply said document forms 0. So this just means go and get me the very first form on the page, this above, so I'm presuming there's only one in the story, and then .submitted. So this is to say, like in JavaScript, not only can you do things like trigger alerts on the screen we've seen thus far, like those dialog windows, you can similarly, with JavaScript through code, automatically submit forms. So it doesn't matter if you're using post. It doesn't matter whether you have an actual button that has to be clicked. It doesn't even have to be a human that clicks a button, okay? It could be your browser automatically executing this JavaScript code in the browser that just submits the form for you on your behalf, which is in essence, cross-site forgery requests. If HTML like this exists in the website that you're visiting to, some bad place, you can nonetheless trick people into executing operations across websites, cross sites, in Amazon.com in this case, even though their users yourselves are not on Amazon.com. So that's the cross-site aspect of this attack. It's a request forgery in the sense that it's all sending the right information across, but it's forged by the adversary. So it's not coming from Amazon.com, it's not coming from the developers themselves, but it is this simple because, and if Amazon.com didn't defend against this kind of attack, then there's nothing really stopping me or you from including code like this on our websites, somehow tricking people to visiting the websites and then having products sent automatically to them, buying loads of toasters at the door, assuming that they have an Amazon account, are they already logged into it with some other tab or maybe some session, at least early in the day, for instance, that would work. All right, so just how can we defend against it before I show you an example that even though when there's JavaScript code already automatically including a submission of those forms, which again, I'm saying might have enough information in them just in order to buy something on our behalf, well, we can defend against that. We can include something a bit like this, a special token of sorts. And it turns out that this is a very common way to address this problem by having the server not just output a simple HTML form, but just to output another form that additionally has another value, often hidden as well. And my convention, again, in some worlds, is called a CSRF token, which is just a fancy way of saying that it has an extra value, okay? But this value, this extra thing, is meant to be typically random, and I've chosen something, and it's pronounceable here, 1, 2, 3, 4, A, B, C, D, okay? But just assume that this value is generated again by the server. It might have a bunch of numbers, a whole bunch of letters in there too, but the point is that it's randomly generated for the user by the server. Why is this important? The implication of this mechanism is by having some web server output not only the product ID, but also the button inside the form that they might be trying to implement by this buy now feature. The point is that that server should also be generating some secret, some randomly generated bit of information inside that server as well. And in the case of HTML as well, that server should remember that value by using its own database, its own session store, some other mechanism. The point over there is that only the server, Amazon in this case, knows what that value should be, only the real place for you, for this specific user. So a hacker, like even if they trick you into visiting the website where they have HTML that looks a bit like this, the hacker, unless they've also hacked Amazon.com, which is, again, a separate case, another story, but they would have no idea what that random value is in the fact that Amazon.com, the actual place, the one that's hosting the buy now buttons, because again, if it's just a hacker on the internet, they haven't taken over Amazon.com, okay? They haven't taken over your computer itself. They're just trying to trick you into visiting a web page on their own site that has HTML like this, and they wouldn't know what value to put there. They have to guess. And yeah, they could guess 1, 2, 3, 4, ABCD, but assuming it's more random than that, it probably will be. The odds are that the hacker guesses your CSRF token is, small and probably not going to happen realistically. So even now, if you do visit a web page that does contain this HTML and even does have some dodgy JavaScript code that automatically submits forms on your behalf, because again, if the hacker doesn't know what the CSRF token is, well, Amazon.com or the server that's going to be doing this, they can just ignore the request. They can ignore the buy now request, and they can just throw up an error message or something just went wrong or the like. But the point is that only the real Amazon.com should be able to generate and remember the CSRF token, and therefore they can then validate cross-server side that it is indeed you who intends to buy something now. A hacker, like if they can just put a blank value or kind of any other value there too, it's not going to be validated server side, because again, the server realizes, that's not the real value for Marco, like that's not the value I'm using for you, that's made up, and I'm not going to trust it. So again, do not trust client-side validation. Very common technique, okay? It does require a bit more complexity on your side. Often you can use a few methods of doing this, like there will be libraries, there will be third-party libraries or code that other people have written before that would allow you to just add this functionality to your own software that you could just add in. But you just need to know that the threat exists, okay? You need to look for a solution that you need to implement, but almost as always, like a library is the answer to the problem. So let me show you an example of this, just to show you what I mean. If you go over to the hack explaining lessons again, just a short one. If an attacker can forge HTTP requests to your site, they may be able to trick your users into triggering unintended actions. I just thought this would be nice and sweet to show you. So I'll read aloud. When creating a website, we tend to code the client side and the server side together. We build the pages and forms a user will interact with on the client side. So me clicking up here and doing things this side is client side, but then the server side URLs that respond with the user performs an action. However, requests can be triggered to the server side code from anywhere, not just the client side code we write. One of the most straightforward, the powerful aspects about how the internet is designed is it allows linking between sites. We call these things RESTful APIs. But it is also the cause of a common security flaw, cross-site request forgery. That happens when a user is tricked into interacting with a page or a script, maybe sometimes automatically or manually, for a third-party site that generates a malicious request to your site. So all the server will see is a HTTP request from an authenticated user. Just to paint a more obvious answer, okay? So here's, what's wrong with my pen? Why is that not working now? Have I been hacked? How bizarre. I'm baffled. I don't know why that's not working. I could definitely recognize this. Okay, well, never mind. Sorry, I can't draw. But I was going to say, if you have, so just imagine in your mind's eye, there being 3 parties. Maybe I can draw here. Can I draw here? Will this work? I'm baffled. I don't know why it's not working. Okay, at least I can do that. So if I have, in this case, 3, I was going to move away the second I press it, right? So you have Amazon.com. I'm going to say that's like a real website, okay? The real deal. And then you have hacker.com, this story that we've got, hacker.com, which has honeypotted you. You've landed as a user to hacker.com. And then this page here with this embed is also going to serve up to you a bit of JavaScript code, which is actually going to secretly funnel off and do that buy now link. It's going to go off and send an authentic HTTP request, a post or a get, to the real website, which from their perspective, they're just going to see an authenticated user, because chances are, like me, you have a lot of tabs open, you have a lot of active sessions going on, you have a lot of cookies still built in. If you can target that and you can forge a request that seems on the surface to look real and proper, then how can you tell apart a good request from a bad request? Okay, so an attacker takes control over the form of the data, and we saw that what that looks like in HTML, sent in the request to cause the mischief. Imagine that you run the microblogging service that allows your users to tweet your opinions at each other with, Twitter, okay, guys. So Mal is a hacker who's noticed that the posts on your service are created using GET requests. That means all the information is carried out in the URL of the HTTP request. So there we go. So this is this horse knew karate, and there is a little bit more fishiness going on there. Mal modifies a post creation URL to include a malicious payload. Now he has a way to find some way to get a victim to visit the URL in the browser. And that can be done with all sorts of ways, either just by sending you an email, you clicking on a link, having an image kind of display automatically to the page. I've talked about examples. Because one of your poor people here, he's got no eyes, he clearly is blind to us what's going on. Mal has been able to guess his email address. And that could be very well the case. It could be leaked, it could be, email addresses aren't that hard to come by. Seems like a very dangerous thing to do. So there's an email being sent to Vic. Has science gone too far with a bit of a researchers have taught the horse how to do karate. I would click on that. I'm interested. So Mal sent just a kind of clickbaity article or some kind of phishing attempt pointing to his crafted URL. Vic clicks on the link. Who wouldn't? So your server, again, the point in the story is that you've somehow, whether that's automatically or not, this example here requires his input, but I was showing you an example. You don't even need that. Like JavaScript can just do this automatically. The point is, though, that upon rendering that image, upon rendering that link, that malicious injection has gone off and done a separate attack, like a separate form to an authenticated, a real authentic website. Your server, Amazon in this case, interprets a request as Vic writing a post and creates a new item on his timeline. So in this case, he's not being tracked into, or he's not going to be tricked into buying something from Amazon. He's being tricked into, writing something he doesn't intend to on Twitter. This is how these things propagate. That's how you become part of a botnet, by the way. You click on a link and then you get infected and you pass it on and then other people find out and blah, blah, blah. This is not the action that Vic intended. He may not have quite noticed what just happened. Wait, I didn't post that, did I? Has this ever happened to you? But you get your social media presence or you think you've been hacked, or some kind of automated bot has taken over your account by the seams of things? If that has happened maybe now or maybe in the past before, this is probably symptomatic of how that happened. That post is designed to be enticing enough that when other people, again, clickbait, right? I would click on this. Avoid just, if you can, bit.ly. That's if I remember, that's like a very cheap, if not free, hosting platform. Oh no, I'm wrong. So it's a shortening service. But it's also not entirely revealing for us, It just happens to be, I don't know, maybe. Anyway, so when they do, they'll be tricked into the same way we was. And then again, that gets passed on, that gets passed on, that gets passed on. So now you have a worm on your site like we discussed yesterday. So each user that clicks on the link will open up another set of potential victims. And it goes on. All right, so it will talk about how that is how that can be solved. One way that we can actually solve the problem is that doesn't involve outputting HTML at all. It's also possible to send those links with HTTP headers also, as might commonly be the case when a website's really heavily using JavaScript code. It's using JavaScript to talk to a server, even without HTML, with all the same values can be sent with this other mechanism as well. So again, if you are interested in these kind of web attacks especially, Hacksplaining probably does a good job of this, but you might find it interesting to have a look at the Open Worldwide Application Security Project, OWASP, which again has a documentation or discussion of recommendations for this kind of request forgery, these kind of web-centric attacks and more. Okay. Cool.